In this video, we will learn a recursive definition of the set example. So in this example, consider the below recursive definition of the set. So this is the definition, recursive definition of the set. Please fill in the below table, which is supposed to show new elements generated in the fourth execution of the recursive step. Give all of the strings of length 6 of the set L with no repetitions. Give the number of strings of length 6 of the set L and give the number of all strings of length 6 constructed out of the elements of the set A in P. So here, in order to solve this question, first of all we need to see this definition. According to this definition, the basis is that an empty string belongs to L. And now in the recursive step, there is a S string that belongs to L. But how? S can be at the beginning and then AB. A can be at the beginning of the string and then there will be B. And then I take my pen here and then explain. Here, this is a string. This is AB, set AB, na? Here, okay? Or a string can be in the center, A and B starting and here string at the start but B, A at the end. Similarly, a string that at the start B and ending with A. So here in this table we have excuse me, written all of the recursive steps, all four conditions, that S can be at the start, S can be in the center of A, B at S can be at the start, but B, A at the end of the string and B at the start and A as at the end. Now suppose we have A, B, A, B. Okay, so how we will get this 6 length, string of 6 length 6, like here AB, AB, AB. Okay, so this is S. Why here this S? Because of this. And then at the end A, B. Similarly, for here, at the start we have A, at the end we have B, and this string will come here. AB, AB. Now here A, S at the start, so A, B, A, B, and then B, A at the end. Here B at the start, A at the end, and S is in the center. So B, A, and this string is coming here, A, B, A, B. So in this way we will fill all the graph, all the table. Maybe I make here S. So what is S? S is this, like A, A, B, B. Okay, now A, B. What is A, B here? Maybe I pick a A, B. Okay, similarly A, B here, B, A at the end, here B at the start, A at the end, and now I am going to write the S, and S, as I have picked the red, this is S. Okay, here I say in the center S, A, B, B, here at the start A, B, B, here in the center A, B, B. Okay, so according to this these recursive steps, we will have these sets of strings after the execution of fourth. We see here in the solved example, like I have done this already here, and the number of strings of length 6 in L, we need to find this thing. We need to find the strings of length 6, no repetition. Okay, so if we know these answers, so we can say these are the strings that have no repetitions. Okay, these are the strings, and then in the next question, the number of strings of length 6 in the set L, that is 14. Okay, it is basically 14 strings, and the number of strings of length 6 constructed out of the elements A, B is 2 raised to the power 6. This is, you need to understand. Okay, how we find this, I just tell you here. Like suppose in the set we have A, B, na, two elements are here, A and B. So why 6 raised to the power 6? Because we need to find the string of length 6. So there can be 64 different combinations of A and B with the length 6. So here this is a simple formula that how many elements are there in the set. There are two elements A and B, and what should be the length of the string? The length of the string is 6. So 2 raised to the power 6, that is 64. So there can be 64 strings, possible strings of length 6. Thank you.